Hello students, this video is related to the explanation of the questions that I have given you earlier in the worksheet. The first question was, in a given circuit you have resistance, a electric device that is electric lamp bulb, which also has a resistance that is 20 ohm. So we have two resistance in series and current I is flowing through it. This is ammeter which is measuring the current, and this is your battery, okay, which is giving 6 volt of potential energy to the given circuit. Okay. First of all, in this question you have to find the total resistance. Total 2 resistors are in series, so total resistance will be 4 plus 20, that is 24 ohm. Okay. Current through the circuit. Obviously we know that in a series circuit current through the resistor is same. In a series connection current is same in both the resistors, so current will remain I. So I is equal to, from Ohm's law, V is equal to IR. So I is equal to V upon R. Okay. So V here is 6 volt, that is total voltage of the circuit, and total resistance is 24. So 1 upon 4, that is 0.25 ampere is your current through the circuit. Then potential, as we are discussing about a series circuit, so voltage across both the circuit is, both the resistor is different. So potential difference across lamp, that is V2, is equal to I into R2, obviously total current into the resistance of that particular resistor. Okay. Similarly, we have a conductor here that is opposing by 4 ohm resistance. So it is Vi is equal to I into R1, V1 is equal to current into resistance. So this is your answer. The next question was, you have 3 resistors, you have to find their total resistance when they are connected in series and parallel. Obviously in series we will add the value of resistance, and this is your answer, and in parallel connection you will solve by using this formula. And remember that when you have solved it up to this, then you have to reverse it to find the total resistance, okay, because this whole formula is going in reverse. To find the value you have to take a inverse of it. Okay. And the next third one is, you have 2 circuits in which you have to find the total resistance between A and B. Here A and B and here A and B. Firstly, here you have 2 resistance in series, obviously, but the total resistance this and this one will be in parallel, because here they are dividing differently and again they are joining here. Okay. So resistance between A and B find करने के लिए, the first thing is R1 and R2 are in series. So the total resistance here will be 6 plus 6, 12 ohm, and this total RT is in parallel with R3. So you will find the answer like this, and this is your final answer. Here first of all, these two are in parallel. So between A and C resistance will be 1 upon RAC, 1 upon 6 plus 1 upon 6, that will be 1 upon 3, and R resistance between A and C will be 3 ohm. Similarly, resistance between C and B, again it is in parallel, 1 upon 6 plus 1 upon 6, it will come out as 3 ohm. Okay. So resistance, now we want, now these two systems, this system and this system are in series. Okay. So the total resistance between A and B will be RAC plus RCB, that is 3 plus 3 is equal to 6 ohm. Clear? The next question is, in next question they have given you that you have 3 resistor connected in series, and this there are 4 set of these type of resistors that are connected in parallel. मतलब we have 3 resistor in series, then the series connection, जो ये series connection है, they are connected in parallel, obviously. ठीक है. So each resistor has resistance 2 ohm. Okay. So the total resistance of each set will be same, that is 2 plus 2 plus 2, that is 6 ohm. 6 ohm resistance here, 6 ohm resistance here, 6 ohm here and 6 ohm here. So, the total resistance in when they are taken in parallel will be 1 upon RT is equal to 1 upon 6 plus 1 upon 6 plus 1 upon 6 plus 1 upon 6, because these are connected in parallel. Okay. So, the total resistance will be 4 upon 6, that is 2 upon 3, RT is equal to 3 upon 2 ohm. The next fifth question, they have given you that you have a 1 ohm resistance wire which is connected in a series with the combination of two parallel resistors 6 ohm and 3 ohm. Okay. Obviously, first of all we will find these two systems are in series. So, first of all we will solve the parallel one. The parallel combination resistance will be 1 upon 6 plus 1 upon 3, that will come out as 1 upon 2. So, the total resistance of the parallel connection will be 2 ohm. Okay, and the total resistance of the whole system will be 1 plus 2, that is 3 ohm, because these two are in series combination. Okay. The next one is, you are given with the system and you have to find the resistance between A and B. So, obviously, we have to find between A and B. So, these two resistors are in series and the total resistance of these two resistance is in parallel with this one. Okay. So, R1 and R2 are in series. So, simply 3 ohm. So, this system will be 3 ohm which is parallel with this one. The total resistance will be 1 upon RT is equal to 1 upon 3, which is resistance of this, and 1 upon 1.15. So, this is 1 upon 3 plus 10 upon 15. We have solved it and the answer will be 1 ohm. In the same way, in next you have to find the resistance between A and B. So, we have 3 arms, this, and this, to go from A to B. These 3 ways or these 3 paths are parallel to each other, arm ACB, arm ADB and AB. Okay. So, in this path ACB, both the resistors are in series. So, resistance of ACB will be 3 plus 2, that is 5 ohm. In the same way, resistance of arm ADB, that will be 3 plus 2, 5 ohm. But these 3 are in parallel, 1 upon RACB plus 1 upon right here RADB plus 1 upon RAB. They all are in parallel. So, solve it and this is your answer. Okay. And then there is 7th question. In this question, you have 2 resistors in parallel connected with the battery. Okay. You have to find the total resistance, current through each resistor. Okay. Total resistance will be, obviously, clearly they are in parallel. So, 1 upon 4 plus 1 upon 6, simply you have solved it by taking inverse also. Then current through the battery. Current through the battery will be the total current flowing through the circuit. So, the total voltage divided by the total resistance, that is 6 upon 12 divided by 5. So, it will be 5 upon 2 ampere. In the same way, current through this 4 ohm resistors, voltage is same, that is 6. Okay, this one is wrong. So, here V is 6 and the resistance is 4, it will be 3 by 2 ampere. Okay. And here it will be 6 by 6, that is 1 ampere. Okay. The next question is 8th question. You are given with a circuit and you have to find the value of this X. You have 3 resistors in parallel and this combination, this resistor and this resistor will be in series. Okay. To find this, firstly we will have to find the total resistance of the circuit, or when we find the total resistance, firstly we will solve this complicated one, that is parallel combination. Parallel combination will be 1 upon 12 plus 1 upon 6 plus 1 upon 3, and after solving it we got 12 upon 7. Okay. So, the total resistance will be 2 plus 7 12 upon 7 plus X. This is the total resistance of the circuit, and the total current flowing through the circuit will be V upon R. V is 6 volt here, that is 6 upon total resistance is this. We have put this value here, it clearly. Okay, this is the total current that is given here by ammeter, total current, total voltage, and this is the total resistance. Okay, now we will have to solve this equation to find x. See here, we have cross multiplied it. After cross multiplication, 0.4 into 2, okay, and then by opening the bracket, 0.8 plus 4.8 upon 7 plus 0.4 x is equal to 6. 0.4 x remains here, and we have solved this one. 0.8 plus 4.8 upon 7, LCM 7, 10.4 upon 7. When we will convert it in decimal, it will come out as 1.48. Okay, so here it is plus and here it will be negative. Okay, 6 minus 1.48, it will come out as 4.52 divided by 0.4, and when you will divide, you will get answer 11.31. Okay. The last question is, you have 3 resistors connected in series and you have to find the value of this x. Okay, current I, that is 1 upon 6, is flowing through the circuit. This is your battery. Again, I is equal to V upon R. V here is 1.5, 1.6 is current. You will cross multiply this equation, the total. Obviously, total resistance will be series 6 plus 2 plus x, and you will solve this for value of x. Okay, so this is all about your worksheet. Hope you have understood.